Sometimes we have to do integrals that involve powers of sine and cosine. Now, before we get started, you need to remember the Pythagorean theorem. And a lot of times we're going to need to be solving for sine squared or cosine squared. So just get very comfortable making this substitution. Don't forget your square though. Or you may need the half angle formula for sine squared and cosine squared. Now, here are some general guidelines for evaluating integrals that have products of sines and cosines. Now, 1 and 2 are very similar. So for number 1, suppose the power of sine is odd. Now, what does an odd number look like? An odd number can be written as 2k plus 1, where the even number is just 2k. Now, you also need to remember that if I have, say, x to the 2k plus 1, I can write that as x times x to the 2k. And if I have x to the 2k, I can write that as x squared raised to the k. And that's all we're doing here. Instead of x's, I'm using sines and cosines. So here, if sine is odd, I'm going to save one of those powers, and I'm going to save one sine for du. And that's going to leave me sine to the 2k, but I'm going to rewrite that as sine squared to the k. And of course, cosine just tags along. It hasn't changed at all. Next, I'm going to replace sine squared with 1 minus cosine squared. Now, this will be ugly, but you can multiply it out. Here will be du, and you will have a variety of cosines to a number of different powers here. Similarly, if the power of cosine is odd and positive, pull out one of those cosines, and you're going to use that for du. So I have cosine to the 2k, and I'm going to write that as cosine squared x to the k. And then I'm going to replace cosine squared with 1 minus sine squared, all raised to the k. So here will be du, and you'll be able to multiply this out, and you'll have a number of sines to different powers. Depends on what k is. Now, if both sine and cosine are even and non-negative, then you're going to have to use the substitution sine squared of x is 1 minus cosine 2x, or cosine squared is 1 plus cosine 2x all over 2. Let's try one. Suppose I want to find sine cubed x cosine to the 4th x. Now, remember, let's find which one is odd. Always look for the one that is odd, and the one that is odd is sine. So I'm going to rewrite sine cubed of x. I'm going to pull out one sine of x, and I'm going to use this one for dx. And what am I left with? I'm just left with sine squared. Now I'm going to replace this. All right, and you can do this all up in the integral, that's fine. Sine squared is 1 minus cosine squared. So my integral of sine cubed x cosine to the 4th x dx is equal to the integral of 1 minus cosine squared x times cosine to the 4th x. Now I'm going to pull this sine x and put it on the end, because this is du and I want to hang on to this. So this becomes the integral of cosine to the 4th x times sine of x dx, so that's my du there, minus the integral of cosine to the 6x times sine of x dx. And for each of these, I have, the substitution. And I'm able to integrate this using the generalized power rule. So this is minus cosine to the fifth of x divided by 5 minus a minus plus cosine to the seventh of x divided by 7 plus c.